x2 and x3, and there is one target variable. Okay, that is y. I've already declared it, so we will declare a numpy array for it. Okay, and I will be like pasting this to the chat also, so that if any one of you are performing it now. Okay, got stuck. And it's not getting peace, and I don't know why. No, it's done. So this is the input that we are taking, that is the x variable, and this is the target variable. Okay, so this is basically x1, x2, x3, and this is the target variable corresponding to that, and x1, x2, x3 similarly, and there are 15 examples. And one more thing, we have to declare the data type as float. Okay, now after declaring the inputs and the target variable, we will be converting it into tensor. Okay, so for doing that,
Sorry, just to be clear, the input is X and target is Y, is it?
yes, like input feature, no,
Yeah. I see.
we're declaring it as inputs and this is the targets. Okay,
I see.
okay, yeah, fine. So now converting it to tensor, so it's like torch.com numpy similarly for targets. Now you can check by printing it. Okay. Now we will be now declaring W and B, what is that, the weights and bias. Okay. So for that, we will be doing first by declaring it randomly. We will call this random function torch.rand, and there will be only one row. Okay, so that's why one, and the three columns, so three, and we have to turn on the gradient requires grad is equal to true. Similarly for B,
What is W?
huh? Excuse me.
I mean, what is W here? Weights.
Weights and B is bias. The
Okay.
parameters. Huh. Now we will declare the linear regression model. So we all know, right? The function fx is equal to w1x. Here it will be w1x1 plus w2x2 plus w3x3 plus the bias. Okay. So it will take the x or the input as input, and we will be returning x at the rate w dot t. This is the transpose. and plus the bias. And this address is basically matrix multiplication. Okay, it is multiplying x with the transpose of the weights. Now we will call the and print and check the b and w value also. Now we will check how our linear regression model is working. So here we will prediction is equal to linear mm, model inputs. I will print it. And this is the actual output or the actual target variable. So this is it. So we can see that it's like there is a huge difference, and we can't obviously expect by initializing randomly w and b. So for that we will be performing the gradient descent algorithm for obvious reducing the loss, and we'll get the w and b from there, for which we will be getting an output which will be more or less close to this actual outputs. So let's
Could you just tell what's the dimensions of x and w actually once these matrices? Could you go?
yes. Huh.
Uh, so it's like this entire row. It's just sorry, I was a bit stuck.
Mhm.
Number
Yes.
of rows corresponds to the number of rows in the matrix, is it?
Uh, can you please come once more?
Yeah. When we say W, W is not a vector. W transpose is a vector, is it? W transpose is n cross one matrix,
Yes,
is it?
yes, yes, yes,
And
yes,
W
yes,
is one cross n.
yes.
I see. Cool.
Okay, now we are performing the mean square error. Mean square error function we are using for calculating the loss function. Okay, so the formula of mean square error is like the summation of the actual value minus the predicted actual output minus the predicted output uh, s- whole square divided by the total number of examples or the samples given. Okay. So MSC now this is the function to calculate the loss. Or wherever bottom. We will define M as the total number of input examples. Now we will check the loss similarly. Okay. So this is the loss that we are getting. Okay, so there's how to reduce this. For that, we will be just introducing the gradient descent algorithm. For gradient descent algorithm, it's basically it's an optimizing algorithm that calculates the gradient of the loss function with respect to the weights and the bias, and it reduces the loss. So okay, fine. Now, we will be mentioning the epochs. So let it be one
Sorry, I'm
1000 or
getting different loss function. Could you go back? Could you go back above and show what your predictions and targets are?
yes, huh?
Predictions. My predictions don't match either. Okay, I may have made a mistake somewhere. Cool. So,
Okay, can you please tell me your query once more? What?
okay.
Hmm.
No, still the same. It's okay. Cool.
So let's define the epochs as 10,000. Okay. Now, and, for and there will be learning rate, so it let be -6. Okay. Now for I am the range box.
I see, because our weights are different actually. We randomize
Oh,
them, we initialize them randomly.
you're getting the predicted output as different, no?
Yeah.
That is obviously because of this. If you
Right.
fix it to 0, we will fix it to 0. Then, like if you give all this weights at 0, like starting from 0, then I think, or anything that a fixed number, then you will getting the same predicted output.
Got it.
Mhm. First, we'll be calculating MSC. It's it's loss dot backward because we need to calculate the gradient. Okay. Now with dodge dot no grad. mm, 0. Now setting the gradient 0 because we don't want like the combination of the newly
Hello.
computed. Excuse
Torch dot no underscore grad. What does this function do?
Okay. This
You
function.
can. There's a user defined function or it's from the library.
No, it's basically what it does. It's like you don't want any, like this the grad requires grad to make the requires grad function to be false for the loss. Okay,
Grad function. Acha, okay.
got it.
And why are we multiplying it with LR?
Because it's the formula, no? The learning rate, you know, right? The gradient descent algorithm. Until converge, we have to compute this, no? Like W is equal to W minus learning rate into the derivative. To converge, we have, you know, this algorithm, right? I don't know.
Just a simple thing. I mean, why are we setting the grad as false for loss function?
Uh, you may or may not, because we are not like actually calculating the gradient with respect to torch. Okay, we are calculating gradient on torch with respect to sorry, on loss with respect to weights and bias. Fine. It basically reduces the memory consumption for the computations.
Okay.
Sorry, zero. I didn't get that.
Uh-huh.
Could you show the code? Yeah,
This thing.
yeah.
Okay.
That's it. Yeah.
We are setting this because to avoid the, you know, the mixed combination of the um, previously computed gradient with the newly computed gradient. It will be running.
So this
It will
basically
be.
sets grad variables to zero, is it?
Hmm? Yes,
This
yes.
basically
Grad
sets.
where. Yes.
I see.
After this, we will predict again.
Upasana,
Yes.
can you please explain me the last print statement?
This thing. This one.
Yes, the last print statement.
What you want to know?
What exactly it is doing?
It's just printing the epochs and the loss that is getting in every iteration. We have running it for 10,000 epochs, right?
Hmm.
The each every epochs it's printing the loss that we are getting every time.
Okay. Okay.
What?
Okay.
What does
So now,
dot no underscore grad is doing? Please explain once again.
how what?
Does talk dot no underscore grad is doing in the previous?
This one?
Yes, yes. No.
Ha.
With talk dot no underscore grad.
This is basically what it's doing. The loss, we are not finding the gradient like any gradient with respect to loss. Okay, what we are finding, it's basically we are calculating the gradient of loss with respect to the weights and bias. This function, what it does is basically uh like puts the requires grad. You can see that if we have requires grad to be true for W and V, but for loss we are setting it to be false. And basically what it's doing is reducing the memory consumption for the like computations and all.
After that, we are doing b dot grad is equal to dot zero. What is that doing?
This thing, no.
Yes, yes.
We are just setting the gradient to be 0 so that we are computing this gradient each and every iteration. No. So for because like we are computing one gradient now, after one iteration we are computing another gradient. So like for avoiding the combination of the previous and the current gradient, so we are just setting it to be 0. Is it okay?
Yes, yes.
Fine. So now you can check. This is our predicted output, and this is the actual target variable that we have given, and you can like see that we have like got a like good result. We can like it's the margin is not that high that we have like got previously, no? This was our previous prediction, and this is our current prediction by applying the gradient descent algorithm. Okay, fine. Is there any other queries?
Should we plot it once, I guess, to see
Plotting. Okay.
the new prediction versus the inputs?
Okay, fine. And next. Second.
Sorry, what's your final loss value?
Final loss value, it's okay. I have to put it's this only, no?
1.04 is it? Yeah, mine is 16 for some reason. Okay,
Hmm?
cool. For me it's 16 for some reason. It's okay.
It's 16.
Yeah, for me. The
Ha,
final loss value should be same, right?
what is the epoch, number of epochs that you have?
Just a second. 10 power 4.
10 power
10,000.
4. Okay. And it's for okay, 10 power 4. For me, it's I think 10 power 5. 1 lakh.
Oh, I see. I see, I see, I see, I see, I see. Cool.
Ah, fine. Got detached, right? That was 80. That's not. Okay. Mhm. What's that function?
2 numpy, I think.
Mm-hmm.
I think
It's
it's 2
one.
underscore numpy.
1 second, 1 second. 2. 1 second. No, it's like what this. No. Fine. It's not. Is it visible? This
I
green
think
one is no. This green one is the dark green one is the actual, and this all
sir,
yeah,
regression line.
represented line. Okay, I can do this also.
Yeah.
Is it visible?
No, this will connect all the points. Vinay. I'm saying the regression line y is equal to theta x plus theta 2. This one.
Okay, okay. Fine. I will check in and I will do an I will post it on Teams only. Okay.
Upasana, can you just share this
So
notebook?
notebook. Ha.
Yeah,
Okay.
just like for viewing. Yeah.
Fine. I will do that. Okay.
Yes, thank you.
So fine. So let's end it here only today. Okay.
Thank you.
Hello.
Yes.
Yeah, this is our first hands-on session. Could you share the previous notebooks and recordings?
Yeah. Recordings are already there in Teams.
Okay.
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 And notebook, I will. Okay, I will tell the TAs to share it. Okay. Because it was done by.
Okay.
Okay. Fine.
Yeah, thank you very much.